This is Regents Physics Exam 5 tutorial. I did it on Friday, but the sound was completely missing from the entire tutorial. Now I'm trying to do it again. This is Sunday night. I was sick all day yesterday and I was sick in the morning. So here you go. I'm gonna try. I'm gonna give it a try. All right, so let's do problem number 1. Problem 1 has to do with construction. You move 24-meter east, right? And then you turn around, you use coordinate direction, which is north and west. So you move 35-degree northwest. So 35-degree northwest. Okay. And then this is 35-degree northwest, and you move 36 meter. And then this is 24 meter. You draw 24 meter again. And then you draw this one again, and this is 145 degree. I'm going to draw it to the scale on the paper, so then you're going to understand it better. So this is 145, this is 145, this is 35. Okay, so this is the result, and I'm going to use the red color. If I do have red color, I don't. Okay, so this is a little bit more than 90 degree. So this is a little bit more than 90 degree. Okay, so 90 degree would be this, and this is a little bit more than 90 degree, but this is the resultant, and resultant is r squared is equal to a squared plus b squared plus 2ab cosine 145, because the law of parallelogram takes the angle between the two vectors, the tail and tail or head and head. So r squared is equal to a squared is 24 squared plus b squared is 36 squared plus 2a 24, b is 36 cosine 145. So r is 21. So the size of this one is 21. Let's do it on the paper. Let's see. So 12 meter is 1 centimeter. Then I have to do, this is 2 centimeter. 2 centimeter is 24. So this is 24 meter. 2 centimeter is 24 meter. Okay, so 12 meter is 1 centimeter. Okay, now I'm going to have to make 35 degrees. This is between 40 to 35. All right, so now 36 meter, what is our convention? Our convention is meter centimeter. So 36, what is it? 1 centimeter is 12 meter. This cancel. 12 goes to 36. 3 times 1. Okay, 3 times 1 is 3 centimeters. So we have to go 3 centimeters. This is 3. Okay, so we are doing 3 centimeters. Okay, so this is 145 degree. Why this is 145 degree? Because 145 plus 35 is 180. Okay, so this is 145. So we have to have 145 here. This is 145 is right here. Okay, so this is only, we're gonna go only 3 centimeters. Okay, so great. Now we're gonna do this one. This one is hopefully only 2 centimeter, because that has to be 24. So this is 2 centimeter, and it is yeah, I'm trying to draw it to the scale, but it's very difficult to draw it to the scale, but hopefully it is. Okay, now this is a parallelogram. This is the nice parallelogram. Now we're gonna draw the resultant vector. So the resultant vector, this is 90 degree, by the way. This is 145. So this is 145. I'm gonna write 145 here. So this is 35 degree. This is 145. This is 145. This is 35. And I'm gonna draw the resultant by red. So this is resultant. This is resultant. 2 centimeters. So this is 1.8 centimeter. So 1.8 centimeter. So 1.8 centimeter times, here is centimeter, here is meter. So we have 1 centimeter is 12 meter. 1 centimeter is 12 meter. So centimeter cancel. 12 times 1.8. So 12 times 1.8. That is exactly 21. Very nice. 21 meters. and the r square is equal to a square plus b square plus 2ab cosine 145 is r squared is equal to 24 square plus 36 square plus 2 24 36 cosine 145 is going to give you exactly same thing. You're going to go to the calculator, you're going to write 24 square and then plus 36 square plus 2 times 24 times um, um, 36 cosine 145, and that's exactly gives you 20. So let's go over problem number 2. Problem number 2 is so let's go over problem number 2. Problem number 2 is very easy. Problem 2, you have you are on the top of a building, and again height h, this height is given 30 meter. This is ball A and this is ball B. The ball A and ball B, they both hit with same velocity v, right? So you drop a ball with initial velocity, you throw a ball with initial velocity 20 meter per second at 90 degree. So you throw it like this, 20 meter per second. Since VA has to be equal to VB, finding this one will allow you to find the height. So VA square is equal to VI square plus 280. So VA square is equal to VI square. What is it? 20. So 400 plus 2 times 10. G is 10. Negative 10. 2 times 10. 2 times negative 10. Negative 20. Negative 20 times negative 30. So 600. So VA square is equal to 1000. So since you are saying that this initial velocity is 0 because you're dropping it, since you're saying VA is equal to VB, you are basically saying VA square is equal to VB square. They're the same thing. So VB square is equal to VI square plus 2AD, right? So VB is equal to VA. So then you can say 1000 is equal to VA is 0 because you're dropping it, plus 2 times negative 10, which is negative 20, H. So 20H. So H is equal to 0, 0 cancel, 50. So the height is 50 over here. So let's go problem number 3. The problem 3 is very simple problem. I gave you, well, it's kind of interesting problem. Why? Because a 1200 kilogram car, right, is moving for 16 seconds. The first 4 seconds is speeding up. The second 4 seconds is moving with constant velocity. Then from 8 to 12 seconds is slowing down, and 12 to 16 seconds is at rest. So you see Newton second law in the beginning for 4 seconds, and then you see Newton first law from 4 to 8 seconds, and 8 to 12 seconds you see Newton second law again, and 12 to 16 seconds you see Newton first law. So it's a roller coaster journey of Newton first law and second law using kinematics, using force to explain kinematics. Let's draw it. Let's draw the graph. This is D, this is 2, 4. So you're gonna draw the line. Okay, so now what I'm gonna do, we're gonna create a table from this. So I'm gonna create the table over here, so it's gonna be better. So the time 0, 2, 4, 6, 8, 10, 12, 14, and 16. This is D, this is B, this is A, this is Newton's law. Okay, so at 0 second, of course, is 0. I'm going to use the red color. At 2 seconds, 4. At 4 second is let's say 16. At 6 second, 32. At 8 second, 48. At 10 second, 60. At 12 seconds, 64. 14 seconds, 64. And 16 seconds, 64. Looking at the graph, what I notice is that from 0 to 4 seconds is speeding up. speeding up. As you see, 0 to 4 seconds is speeding up. What does that mean? Here velocity is 0. Okay. Here velocity is not 0. Here velocity is not 0. So it's speeding up. So we have to find the acceleration. Let's find the acceleration at 4. So d is equal to half at square vit plus half at square at 4. At 4, this is 16. 16 is equal to 0. Vi is 0, of course. Why Vi is 0? Initial velocity is 0. Half a we are trying to find at t at 4 is square. So 16 is equal to half a 16. So 16 is equal to 8a. So a is equal to 2. So acceleration is 2 here, 2 here, 2 here. Great. So acceleration from here to here is 2. So is it speeding up? Okay. So I'm going to make it green. So this is speeding up. Okay, great. So velocity is at. So 2 times 0 is 0. 2 times 2 is 4. 2 times 4 is 8. Okay. 2 times 0 is 0. 2 times 2 is 4. 2 times 4 is 8. Great. Now, 16 to 32. What is the change in displacement? 16. 32 to 48. What is the change in displacement? 16. So there is no change. What does that mean? Constant velocity. So you're going to write 8. You want to write 8. So acceleration is 0 there. So see how fast you can do it. Acceleration is absolutely 0 over there. Okay, great. So all right, great. So 48 to 60, what do you notice? 12. 60 to so you want to write constant. From here to here is constant. Constant means acceleration is 0 and velocity is same, doesn't change. Now from 8 to 12, you see let's see, what do we see? This is 48 to 60 is 12. The change in displacement is 12. From 10 seconds to 12 seconds, change in displacement is 4. So this is definitely slowing down. Okay. So from 64, 64, 64, so this velocity must be 0, right? Velocity doesn't change, so displacement doesn't change. Okay. So if Vi is 8 and Vf is 0, right? Vf divided by 2. So Vi is 8 and Vf is 0 divided by 2. So who is this 4? So velocity is 4 over here. Okay. So with the velocity 4, we can find the acceleration. How? Okay. So we're going to say that Vi is 8, Ti is Ti is 8. Vi is 8, Ti is 8. 8. Vf is 0 and Tf is 12. So Vf minus Vi delta T. So Vf is how much? 0 minus Vf is 0 minus 8 divided by 4. So this is minus 2. So acceleration is minus 2 over here, minus 2 over here, 0 over here, 0 over here. So this is Newton's second law. This is Newton's second law. This is Newton's second law. This is Newton's first law. This is Newton's first law. This is Newton's second law. This is Newton's second law. This is Newton's first law. This is Newton's first law. Now, I want you to see the geometry of this one. The geometry of this one would be so I'm going to color code it. So this is velocity versus time graph. So this is green. So I'm going to do the green. It's speeding up. This is constant velocity. from 4 second to 8 second. This is 8. From 4 to 8 second is constant velocity. So constant velocity, and 8 second to 12 second is slowing down. So it's slowing down, and 12 second to 16 second is at rest. So you're gonna come over here. This is 8. You're gonna come over here. This is 4. This is 8. This is 12, and this is 16. This is the 16-second motion of the car, Mr. Barry's car. So from here to here, the net force is F is equal to ma. So the car is 1200 kilogram, right? Mass. So the net force has to be F net is 1200 times 2, so 2400 Newton. So from here to here, the net force is 2.4 times 10 raised to 3 Newton. From 4 to 8, the net force is 0. F net is 0. From 8 to 12, right? 8 to 12, F net is negative 2.4 times 10 raised to 3. Then from 12 to 16, the net force is again 0. So you see that how the kinematics really connect with how we can do how we can use the force to explain the kinematics. So this is completely a kinematics, and we use the force to explain the kinematics. So if there is a force, then there is an increase of velocity. If there is no force, what happened? The constant velocity. If there is a force, of course, opposite to the direction of the velocity, okay, then there would be acceleration which is opposite to the direction of the velocity. Then of course the velocity gonna go to 0, and then velocity gonna go to the 0. And then there is, if there is no net force is 0, object at rest is stay at rest. Net force is 0, object at rest is stay at rest. Newton's first law. Net force is negative, so object is slowing down. So this is Newton's second law. Net force is 0, so object moving with constant velocity, 8 meters per second, Newton's first law. Object is speeding up, Newton's second law. This is a wonderful way to understand Newton's first law, second law. Problem 4 is one line. So you have 120 Newton object. You apply 60 Newton. As a result, you apply 60 Newton to 120 Newton object. If you don't like 120 Newton, you're always more than welcome to write the mass. So you can definitely write divide by 10. So you can write 12 kilogram. No problem. Same thing. Okay. So now, as a result of you applying 60 Newton, the object is moving with constant velocity. Constant velocity means acceleration is 0. What does that mean? Where the acceleration 0 come from? That has to be equal in magnitude, opposite in direction. Okay. Therefore, it is moving with constant velocity because the acceleration is 0 and force of friction is 60. Okay, so we have to find the mu k. So Fg is 120 Newton, so Fn has to be 120 Newton. Okay, now Ff is mu k Fn. So mu k is Ff over Fn. So Ff is of course 60, and this is 120. So this is mu k is 0.5, and there is no SI unit to mu k, and that is problem number 4. Let's go problem 5. Problem 5, last time you explored that if okay, so let's say mg is equal to g big M small m over r squared. Where this come from? Fg is equal to Fg. Now if g has to go up, m has to go up. If g has to go up, r has to go down. Why? Because this is inverse square law. This is our hypothesis. To make the long story short, G bigger, R is smaller. Cancel. G is 1 over R square. G and M, we're not going to touch them. This time I didn't ask you to touch them. Keep them same. So you're going to say G old, G new, R old, R new. G old is 9.8. We are using magnitude, or even if you don't use magnitude, minus cancel. 10. R old 6370000 square, and R new we're going to try to find out. So you're going to cross multiply. If we do cross multiply, 9.8 6370000 square is equal to 10 Rn, R new. So 9.8 times 4 times 10 raised to 13. Square of this one is 4 times 10 raised to 13, 10 Rn. So this is 4 times 10 raised to 14 is equal to 10 Rn. So Rn is equal to 4 times 10 raised to 14 divided by 10. So R new is 4 times 10 raised to 14 minus 1. So Rn is equal to 4. This is a square. This is a square. This is a square. This is a square. This is square times 10 raised to 13. So then you square it. So Rn is equal to 630 0000 meters. So this is finally Rn is 6.3 times 10 raised to 1, 2, 3, 4, 5, 6 meters. So 6300000 is less than 6370000. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Yeah, right. So our hypothesis is correct. 15 kilogram object, 100 Newton net applied force. I should write applied force. And then force of friction is 50 Newton. Okay, so what we need to know is the acceleration. So F is equal to ma. At the x direction, all the forces Fa minus Ff is equal to ma. So ma is equal to, or we just say ma is the, ma is the Fa minus Ff. So ma is Fa is 100 minus 50. Acceleration is 50 divided by 15. This is 3.3 meter per second square. Problem number 7 is a little bit more interesting than this one. A 10 kilogram box is sitting, right? And there is a friction. Mu s is 0.5, mu k is 0.3. You know that force of friction, mu ffs, ffk. ffs is mu s fn, mu k fn. So mg is 10 times 10, 100 Newton. So Fn must be 100 Newton. Some applied force over here, okay, from 0 to 80 Newton. All right, that means you keep pulling, starting from 0. When applied force is 0, force of friction is 0 by definition, okay. So mu s is 0.5, Fn is 100, so this is 50. Mu k is 0.3, Fn is 100, so this is 30. So friction graph gonna look like this. So this is 50, this is 30. So this is Fa. What is the minimum Fa that will move the box, right? 0 will not move the box. 10, 20, 30 will not move the box. 40 will not move the box. 45 will not move the box. 49 will not move the box. 49.99 will not move the box. 50 is the fs max. So anything more than 50, like 50.0001, will move the box. Okay, so 50, you're gonna write 50. Okay, excellent. So this is what I asked you to do. This is 80. So mu k fn, this is 30. This is 30. Mu s fn, okay, which is 0 to 50. So I have to fix it over here. Okay, so this one is less than or equal to 50. It could be 0, it could be 30, it could be 49, it could be 49.9999, 49.9999, it could be 50, but it never can be more than 50. If it is little bit more than 50, it drops to 30. So this is Newton's second law. This is Newton's first law. This is object at rest. This is object is accelerating. Okay, so that's problem number 7. Let's go to problem 8. Problem 8, I give you a box M. You apply force 40 Newton at 60 degree. That's scenario 1. Scenario 2, you mass M, you apply same force. However, your angle is half. So your angle become 30 degree. FA is same. Angle become 30 degree. If you decrease the angle, acceleration go up. If angle go down, acceleration go up. If angle go down by double, right? If angle 60 degree to if angle go down by half, then acceleration go up by 2, almost 2. So half the angle, we can say, or almost 2, almost, we don't know. Let's see, let's find out. So the first case scenario, let's see over here, scenario 1, fx is 40 cosine 60. So fx is 20 Newton. So let's say m is just 1 kilogram. So acceleration is 20 divided by 1, so 20 meter per second square. All right, same thing, 1 kilogram. All right, so fx is 40 cosine 30. So fx is 35. So acceleration is fx over m. Acceleration is 35 divided by 1. So acceleration is 35. Okay, now you have 35 divided by 20, which is 1.7. So it's 1 times 7, 1.7 times bigger, or we can say almost 2 times bigger. Almost 2 times bigger. If the angle go down by half, acceleration go up by 2. Okay, that's problem number 8. Problem number 9 is vector. So if you have an x-axis, if you have vector A, which is, I don't know, about 30, I don't know what degree angle, I'm not going to make any comment. Let's do it on the, I'm going to have to use the protractor to do this one. So let's use the protractor. For a resultant, this is our A. We're going to draw B. So to draw the B, we're going to just connect the head of A and the head of resultant. So this is B, and B is 2 centimeters, right? B is 2 centimeters. Now what is A? 2.7 centimeter. 2.7 centimeter. Okay, so now let's see the angle. The angle is right here. So this angle is, it shows 70 So this is 70 degree. Okay, so now I have to draw, if this is 2 centimeter, which it is, this one is 2 centimeter, I have to draw this 2 centimeter over here. But to draw 2 centimeter, I have to have, this is 70, so this has to be 110. Why? 70 plus 110 is 180. So I have to draw a dot, one dot, another dot that will allow me to draw a line which is 2 centimeter. So now 110. So now I have to do 2 centimeter. So this is 2. This is B, this is B prime. So now we're going to connect this one, so we're going to call them A prime, and that has to be, A prime has to be 2.7. hopefully it is 2.7. yeah, it is. So this is 110, this is 110, this is 70, this is 70. So we are done. So we now going to measure this one, the resultant. This is the resultant from here to here. This is the resultant. The resultant is 2.5. so this is 2.5 what centimeter, or unit, let's call it unit. Now A square, which is 2.7, plus B square, which is 2 square, plus 2 times A times B times cosine 110, and that is shows 2.7. maybe I made a mistake. Let's see, let's do it again. It's actually 2.7. yeah, it's actually 2.7. This is 2.5. 2.7 is exactly 2.7. is exactly 2.7. If you bring the camera close, you're going to see this is not 2.5. I measured it wrong. So this is 2.7. So the math fixed the measurement. Well, a little bit off, 2.756, but this is close call. Okay. So I'm crouching like this to jump up. This is vertical jumping, right? To do the vertical jump, I have to crouch. Crouch is going to allow me to accelerate. Acceleration going to allow me to have some initial velocity. Initial velocity going to create some displacement. So I'm going to push, all right, during the crouching. Like during the crouching, I'm going to bend my knee. When I bend my knee, as I move up, right, I push the ground. So the ground going to push me. So I'm going to have some force. At that force going to give the acceleration. That acceleration going to give the velocity. That velocity going to give the displacement. Okay, so this is location A, this is location B, this is location C, right? So I'm going to bending my knee, right? So this is y is equal to negative 0.2. This is y equal to 0. I'm going to measure the height from this location. This is y is equal to 0.8. So my vertical jump, right, max height, at max height, this is 0.8 meters, right? This is 0 meter, this is okay. So how much I crouch? I crouch 0.2 meters, right? So now I did not ask you anything. I asked you when I was in the air, right, at location C, that was the max height. What was the net force acting on me? And that is very easy. If I ask you to draw a free body diagram at this location, because when you do a vertical jump, right, at the max height, what you are in free fall, when you are in free fall, anytime you jump up, when you are off the ground, a 70-kilogram man off the ground, what would be the net force acting on him? That's very easy. At that location, a free body diagram would be, since he is in free fall, Fg is equal to mg, and that is Fg is equal to 70 times 10. So this is 700 Newton. Of course, this should be negative because the net force, the direction of the net force is to the down, and that is problem 10. A 4 Newton block is sitting right now. This is the friction diagram. This is force of friction. This is the time. This is 1. This is 0.9, right? You apply some force, right? That applied force accelerate the object. So object is moving. Okay, if the object is moving, what is a friction, the coefficient of friction, coefficient of kinetic friction. So this is F over Fn. So who is FF? You're gonna, since it is moving, you're gonna use 0.9. 0.9 divided by 4, right? This is Fn. Fn is 4 Newton. F G is 4 Newton, because the mass is 4 Newton divided by G, which is 10. So the mass is 0.4, right? If you don't like 4 Newton, you can write 0.4 kilogram, if that makes you feel better. So this is 0.23. There is no SI unit. 12, problem 12, you have a car, 1200 kilogram car is on the road. That is, the car has wheels, okay, and this is the dry asphalt, and that it has mu s 0.85, mu k 0.67. Since the car is moving, right, accelerating, I ask you to find the acceleration of the car. First, you have to find the force. How many forces acting on it? Okay, so first you hit the brake, right? If you hit the brake, what happened? The wheels slow down because of friction. So what type of friction? The kinetic friction. So mu k Fn. So the velocity is getting smaller and smaller and eventually zero, right? I'm going to make this one bigger, I'm going to make this one smaller, and I'm going to make it zero. Okay, so this is velocity vector. So what happened? Why? Because acceleration is this way, because the net force is this way. So you're going to find the net force. So net force is actually Fk. All right, so how much is that? 0.67 times 12,000. So this is 12,000, right? 1200, 12,000. So this is 0.67, this is 8,000. 8,000 watt Newton. So acceleration is F net over m. So F net is 8,000 over m is 1200. 0, 0, 0, 0 cancel. So this is 6.7. 6.7 at what direction? 6.7 at this direction. Negative. Oh, I'm not going to write negative because it's already pointed this direction, meter per second square. Net force is also this direction. Okay. Velocity is this direction, acceleration is direction, net force is this direction. So this car will have velocity over here 0. This car will stop. Next time probably I will ask how long does it take for this car to stop. This is Earth. This is ISS. How much? Distance is 400 kilometers. And since Earth is also round, we prove that from here to here is 637,000 meters. And from here to here is, I did not draw it to the scale, sorry, 400,000 meters. Okay, so you know that Fg is equal to Fg, mg is equal to g small m big M over r squared. So g on the ISS we are trying to find big G big M over r squared. So what is r? R is 637,000. So this is 400,000. So 0.0000776. So from center of the Earth to the ISS is 677,000 meters. So you're gonna write G is equal to 6.67 times 10 raised to negative 11 Newton meter square over kilogram square. Mass 6 times 10 raised to 24 kilogram, and this is 677,000 meter square, and that is 6.67 times 6 divided by 6. 77 square is 4.6 times 10 raised to 13, and this is times 10 raised to negative 11, positive 24. So this is 6.67 times 6 divided by 4.6, 8.7 times 10 raised to negative 11. positive 24, negative 13. So G is equal to 8.7 meter per second square, because 24 minus 24 is 0. Okay, what is the 8.7 meter per second square? So ISS, some of you think that the gravity acceleration due to gravity is 0. No, it's almost 9.8. 14, 15, 16, the sound was missing. Oh, I have to do it again. Very bad luck today. It's happening again and again and again. So 14, this is the graph. So for first 2 seconds, I cover 4 meters. Then next 1 second, I'm at rest. Next 1 second, I'm speeding up, covering 4 meters. And next 1 second, I'm back to right here at 4 meters, covering additional 4 meters. So that's our DT graph, and now our VT graph is going to be very easy. So I'm going to just do it in 3 regions. 4 divided by 2, so velocity is 2. I'm going to use the green color. The velocity slope of this one is 0. So velocity is 0 to 3 seconds. The 3 to 4 second object is speeding up, but at 4 seconds, it is obvious that velocity is 0. So at 4 second, velocity is 0. At 3 second, velocity must be maximum. So why is that? Because area is half BH. So area from 3 to 4 second, it covered 8 minus 4, 4 minus 3. So velocity is 8. So here the velocity is 8. So from 8, velocity is 8 to 7 to all the way to 0. Okay, great. Since this is symmetric, if the velocity, if the acceleration over here is negative 8, acceleration over here is negative 8, acceleration over here is also negative 8. The acceleration is same over here. The velocity is 8 over here, so negative 8 over here. So velocity is negative 8. So this must be a straight line, because the acceleration over here is the same. What is that acceleration? Acceleration is negative 8. How is that? Because VF, acceleration is VF minus VI over delta T. So VF is negative 8 minus VI is 8 over 5 minus 3. Acceleration is negative 8. So if we draw the acceleration versus time graph, acceleration from 0 to 2 seconds, 0. Acceleration from 2 to 3 seconds, 0. Acceleration from 3 to 5 seconds, negative 8. Okay, now we're going to do problem number 15 and 16. 15, y is equal to mx plus b. This point is 4, 0. When the time is 4, velocity is 0. We are not using this graph. We are using this graph. So we're going to call it VT, not PT. So this is not P of t. This is V of t. Okay. So y is negative 8. X is 4 plus b. We are trying to find b. Y is 0. So b is 32. So y is equal to mx plus b. So y is v of t minus 8t plus 32. Now I ask you to do it at 3.2. At 3.2, the velocity is, this is 3. So 3.2 velocity is positive because it's above the x. So 3.2 is equal to minus 8, 3.2 plus 32. So the velocity is 6.4 or something meter per second, but you check. 10 kilogram box, 2 forces acting on it at time 0. 2 forces acting on it. A is 50, B is 70. What theta will allow them to get t is equal to 3 seconds, d is equal to d is equal to, let's say, 4 meters. What angle will allow at t is equal to 3 seconds the displacement 4 meters? Okay, again, this is a optimization, not optimization problem. This is not similar to the 5b, but we're gonna use the dot product. This is fixed, acceleration is fixed. You don't have to maximize the acceleration. Okay, so let's do it. Ax is 50, ay is 0, bx is 70 cosine theta, by is 70 sine theta. This is Fg is equal to 100 Newton. This is Fx is equal to 50 plus 70 cosine theta. This is Fy is equal to 70 sine theta. This is Fn is equal to 100 minus 70 sine theta. This is Ff is equal to mu, I believe I give you a mu k. This is 0.2. Is that 0.2? Mu k 0.2, right? So mu k is 0.2. So you're gonna have 0.2 times 100, so 20 minus 0.2 times 70, 14 sine theta. Okay, so this is our step 1. This is our step 2. Let's see. This is our step 3. F net is equal to fx minus ff. Fx minus ff. Fx is 50 plus 70 cosine theta minus 20 plus 14 sine theta. 70 cosine theta plus 14 sine theta plus 30. This is our F net. So our acceleration is 70 cosine theta plus 14 sine theta plus 30 divided by 10. This is step, still step 4, step 3. 7 cosine theta plus 1.4 sine theta plus 3. This is our acceleration. Step 4, d is equal to half a t square. D is equal to half a at time 3. Acceleration, d is 4, right? We don't have to put that. D is equal to 4.5 a. Step 5, 4.5 a is equal to 7 cosine theta plus 1.4 sine theta plus 3. We're gonna distribute this. 7 times 7 times 4.5, 31.5 cosine theta plus 1.4 times 4.5, 6.3 sine theta plus 4.5 times 3, 13.5 is equal to, of course, 4. Okay, so 31.5 plus 6.3 sine theta is equal to 4 minus 13.5, negative 9.5. Divide everything by 6.3. So you have 5 cosine theta, cosine theta plus sine theta is equal to 9.5 divided by 6.3, 1.5. Okay, now step 6 is add cosine theta minus p. So r is the square root of 26 cosine theta minus p. Tangent theta is 1 over 5, right? You see that 5 sine. So 1/5. So theta is tangent inverse 1/5, which is 11. Okay, so you're gonna say 26 cosine theta minus 11 is equal to negative 1.5. So cosine theta minus 11 is equal to negative 1.5 square root of 26 inverse cosine. So inverse cosine negative 1.5 divided by square root of 26, and that is 1.7. So theta minus 11 is equal to 107. So theta is equal to 107 plus 11. So theta is equal to 119. Yeah, 119 degree angle gonna make it possible over here. So this must be 119 degree. So that at 3 seconds the displacement is formed. So and there is an apple over here at 40 meters above the ground, and there is a moon over here some 3.8 times 10 raised to 11 meter above. Why the earth falling and hitting the why the apple falling and hitting the earth, but moon falling doesn't hit the earth? It's because the apple doesn't have any sideway velocity. The moon has sideway velocity. In fact, moon sideway velocity is 1 kilometer per second. Where does the moon sideway velocity come from? A Big Bang. During the Big Bang, it got its sideway velocity. Okay, sideway velocity has another name. Okay, think about sun, and this is Earth. Okay, and the distance is 15 million kilometers. So this is the Earth tangential velocity or sideway velocity, and this is we're just gonna call this is centripetal force. The Earth sideway velocity, centripetal force come from gravity. Earth sideway velocity is about 30 kilometer per second, I believe. Not sure 100%. Okay, where does the sideway velocity come from? Sideway velocity come from during the Big Bang. So, and also, yeah, from the solar system during the Big Bang. Without the sideway velocity, the Earth would be falling and the Earth would be falling and hitting the sun. Because of the sideway velocity, Earth is falling to the sun but doesn't hit the sun. Apple doesn't have sideway velocity, so it's falling the Earth and hitting the Earth. The moon has sideway velocity, so moon is falling the Earth but doesn't hit the Earth. Okay, here that's it. Okay, next problem. Rope 1, mass rope 2. If you pull the rope with this is mass 300 gram. If you pull, the rope has the limit, breaking limit is 7 Newton. If you pull the rope with 6 fp, negative 6 Newton down, then it's pending forever. Which rope will break? So you're going to do rope 1, mass, and rope 2. So let's first do rope 2. Let's start with rope 2. Rope 2 would be easier. So this is F pole, negative 6 Newton. So this is Ft is negative positive 6 Newton. This is Fg is 3 Newton, and F pole is is 6 Newton. So 6 plus 3, 9 Newton. Ft is 9 Newton. So this is F down, okay, due to mass, 9 Newton. So this is F ceiling, 9 Newton. It cannot handle 9 Newton because the limit is 7 Newton. So this is this breaks. Because 9 Newton is bigger than 7 Newton. So this rope 1 breaks. Rope 2 doesn't break because 6 Newton, number 1, 6 Newton is less than the breaking limit, 7 Newton. Also, it's a long time. It takes long time. The rope can send the information from rope 2 to rope mesh to rope 1. Okay, great. That takes us to next problem. Problem number 19. Recording this is for the second time. The first time I did it on Friday, but there was no sound. For some reason, the sound was missing from the tutorial, so I had to do it today on Sunday. And I was sick all day yesterday. I wasn't able to do it. I'm so sorry. Problem number 19. So so this is 60 meter. This is 110 meter. At what velocity? What Vy is always 0 when you jump off of the rooftop, height h. Then Vy is always 0. What should be the Vx? So you don't land at 100, or you don't land at 120. You land exactly at 110. Okay, you exactly land at 110. What would be the Vx? Okay, very easy. So Dx is equal to Vixt. That's it. So Vx has to be dx over t. It seems like I only need the t. I don't need dx. I know dx. Okay, so this is dy is equal to Viyt plus half a yt squared, and this is 0 because it's given. Dy is 60. This is 5t squared. So t is equal to square root of 12. So t is equal to 3.5. So this is 3.32 meters per second. So the last problem is number 20. I cannot believe I'm solving last problem. And I'm not sure whether the sound is this time is good. So 3 building. This is 40 meter building. This is 200 meter building. This is 380 building. This is you throw something with 90 degree at 30 meter per second. You drop it and you do something. I don't care, as long as you because it's given. The 3 ball, you see 3 ball falling, right? Both fall, all 3 ball falling almost the same time. If all 3 ball falling almost same time, you're gonna find the easiest one, and easiest one is this one. Why is that? Because this is drop. So what are you going to do? D is equal to Vit plus half at squared. So this is 0. Why this is 0? Initial velocity when you drop something is 0. So this is 200 5t squared, because acceleration is g, which is -10. So t squared is equal to 440. So t is equal to 6. If it was 49, then it's 7. If it is 36, then 6. So 6 point something, 6 point, let's say 3 seconds. Okay, so yeah, they all are the same. Okay, so it has not been a fun experience, but anyway, I did it.